To finish up this section, we're going to analyze a few graphs. First, let's find a polynomial function that could be of the form below. Let's say that this x-intercept is at -4, and this x-intercept is at 3. Remember, x-intercepts are the same thing as zeros, which is the same thing as solutions to the polynomial. Those all mean the same thing. So we have the zeros, so we know right away that the function is going to have the form of x plus 4 will be a factor. We also know x minus 3 will be a factor. And we also know x minus 0 is a factor. X minus 0 is just x. So I'll put that out in front. So I have these three zeros at x, -4, and 3. I also know that it has 3 turning points. This is a turning point. This is a turning point. This is a turning point. Since it has 3 turning points, I know that it's going to have at least a degree of 4. The only thing I don't know is that I don't know what the powers are, because right now these exponents only add up to a degree of 3, and I need it to be at least 4. So one of these degrees of these factors is going to have to be bigger than 1. So what I'm going to do is I'm going to look at the individual zeros and whether it crosses or touches the graph at each of those zeros, then that will determine what its multiplicity is. So we've got zeros at -4, 0, and 3. At -4, you can see that the graph crosses through the graph. When a graph crosses through, that means it will have an odd multiplicity. At the 0, 0, it also crosses through the graph, which means it has an odd multiplicity. However, at the 0, 3, or x-intercept, it only touches and reverses and goes back the same direction from which it came from, which means it has an even multiplicity. You can see it looks more like a parabola here, which is an even multiplicity. Crossing through has more of an odd, meaning it crosses from one side to the other, like an x to the third graph. So since -4 and 0 both have an odd multiplicity, they could be 1. But since the 0, 3 touches, it has an even multiplicity, it has to have a multiplicity or an exponent of at least 2. And if I add those together, I do get the degree of 4 that I'm looking for. Now this is just one example of what this might be. Just because these are odd doesn't mean that they're 1. These could be 3 and 3 and 4. Or 1 and 3 and 8. I don't know exactly what they're going to be, but this is one example of what it could possibly be. I definitely know this is even, and I definitely know these have to be odd. So how about this one? Again, we have these zeros at -1 and -3 and at 2. So it has 2 turning points. 2 turning points indicates a degree of at least 3. The degree is always one more than the turning points. So let's look at the zeros and then analyze the graph to determine their multiplicity. So when we look at the 0, -3, it crosses through, which indicates an odd multiplicity. At the graph -1, it crosses through, which indicates an odd multiplicity. And at the x-intercept 2, it crosses through, which again indicates an odd multiplicity. So my function is going to equal the 3 factors multiplied together. This would be the 0, -3. This would be the 0 at -1. And this would be the 0 at 2. And since they all have an odd multiplicity, they could all have an odd exponent. Since the degree is at least 3, they could all be 1. They could be 1, 1, and 3, or 5, 1, and 9. We don't know. But they also could be all 1s. So we'll just show the simplest form.